tutorial. My name's Ian, and today we're going to start getting into some of the math behind how we train our neural network. So I'm going to start with a little quick review of some single variable calculus. Derivative of x with respect to x, that's going to equal 2x. If you don't understand that, learn some calculus. We're going to start with that. Okay, now we're going to move on to some multivariable calculus. So how we do that, we got f, and it's going to be x squared y plus, let's go x y squared. Okay, now how we find the gradient, which is kind of the derivative of the entire function, what we're going to do is take all the partial derivatives of each variable and then put them in a vector. So we compute this. So our gradient of f and x is going to equal a vector of all the partial derivatives in that function. And this little 2 is just the partial derivative. Don't worry. Okay, so when we calculate the gradient, what we're going to get is a vector. And the vector is going to show the rate of change, the greatest rate of change in our function. So it's going to move it in the way that's going to increase the output of our function. It's the path of greatest ascent, I guess, is another way of putting it. Now, how do we compute a partial derivative? It's very easy. What we do, I shouldn't do this. So the partial derivative of f with respect to x, what we're going to do is we're going to take our x variable and do some single variable calculus on it, as we normally do. And we're going to treat every other variable that we have as a constant. So 2x to the y is going to equal 2x, or x squared y. So we take the standard derivative, like x squared 2x, and then we just keep y as a constant. And it's going to be y squared. So another way of looking at this could be like, maybe let's go x3 squared. What would be the derivative of that? Well, we just take away their x and we're left with a constant, which is 3 squared. So if you're having trouble understanding how to use a constant, just kind of plug in a number and you can probably guess what it is. And let's do the other one, partial derivative of x with respect to y. And we're going to get x squared plus 2xy. Okay, hopefully that makes a little sense. Okay, let's graph this out. Let's get a graph and maybe that can help you understand what's going on. So we have a three-dimensional graph. Here's our z-axis, here's our x, and here's our y. So this is kind of like a 3D plane. And let's draw a little function on it. I'm not a very good drawer. So this is kind of like a think of it like a parachute opening, I guess, in a three-dimensional plane. And what we're going to do is find the gradient at x naught, y naught. So how we do this is we're basically going to try and take out the impact of y halves. So what we're going to do, so say we've got a three-dimensional plane, z, x, y, and what we're going to do is kind of shift it so we only have our z and our x-axis. And this is what we're going to do. So this is x, this is z, and picture y just going straight in. And how we'll switch this around, we might get something like this. And here's x naught. Well, we know how to calculate the derivative here. Very easy. We already know how to do that. I should draw this a little bigger. But that's basically what we're doing. We're finding the derivative of z with respect to x. And it's going to look maybe something like this. And we're going to do the exact same for y. And we might get a direction. I don't know why I'm being so messy right here. So our x is probably going to go here. And our y is, I don't know. And this is actually going to give us a vector of greatest ascent into our graph. Now, how this goes back to our neural network, well, we have our gradient. Remember our gradient descent algorithm? We have our gradient of greatest ascent, so what we do is we multiply by -1, and we get the gradient of greatest descent. And then we're just going to update our parameters that way. So if you want to think of it, we're going to assign x to be x plus the partial derivative of z with respect to x times our constant. So remember, this is our learning rate. So we take our vector, or a vector, we multiply it by our learning rate, and then we add x to that, and it gives us our new location. And we do the same with all the variables we have. Now, hopefully that makes a bit of sense. I'm not really going to get into this, but check out some other videos if you need help. Now, we can actually use that kind of gradient descent in our neural network because our variables are intertwined. Remember, we're sending in our first layer, our variables are going to impact on our second layer. And that's why we're going to have to use something called the chain rule. And I'm going to be doing that in the next video. So that's everything for now. Thanks for watching.